to the second episode. So now we'll be talking about types of magnets, as I said in the last episode, types of magnets. So we have two types of magnets. We have the temporary magnet, and we have the permanent magnet. We have what? The temporary magnet and we have the permanent magnet. Example of the temporary magnet, a perfect example is the soft iron, or you can call it iron. So I intentionally put this soft because of something, so we call it soft iron. And for permanent magnet, example is what? Is steel. Example of a permanent magnet is steel, while example of a temporary magnet is what? Soft iron. So what are the differences between soft iron and steel? So number one is that what? As we said, that what? Soft iron is a temporary magnet. Soft iron is a what? Is a temporary magnet. While steel is a what? Is a permanent magnet. Steel is a what? Permanent magnet. What do we mean by temporary and permanent magnet? From the word temporary, what is temporary? Temporary means a temporary magnet is a type of magnet which do not retain its magnetism for a long period of time. It's a soft iron, it does not what? Retain its magnetism. It does not retain its magnetism for what? For long period of time. It does not retain its magnetism for long period of what? Of time. Why? Because it is temporary. So it does not retain the magnetism for long period of time. But when we talk about permanent magnet retains what? Its magnetic property. It retains its magnetism for what? For a long period of what? For a long period of what? Of time. Because it is what? It is permanent. If something is permanent, it means it is very last-longing. So it means it retains. So still being a permanent magnet, we retain its magnetism for a what? For a long period of time. Another thing is that what? Another thing that we can have under a temporary magnet, which an example is soft iron, is that a soft iron can be easily magnetized. It can be easily what? It can be easily magnetized. It can be easily magnetized and what? And demagnetized. We can easily magnetize it and we can easily demagnetize it. Since we can easily magnetize it, why do we demagnetize it easily? Because it is a temporary magnet. So it will demagnetize easily because it will not retain its magnetism for a long period of time. So it can be easily magnetized. That is why it is a temporary magnet. So, but for this one, for permanent magnet, it cannot be what? Be easily magnetized and what? Easily magnetized and what? And demagnetized. It cannot be easily magnetized and what? And demagnetized. So it means if I want to magnetize a soft iron, it will not take longer time. And for it to demagnetize also, it will not take longer time. But for permanent magnet, which an example is steel, it is very difficult to magnetize, and also it retains its magnetism for a long period of time because it is a permanent magnet. So that is why we use what? We use this soft iron. In fact, we use it in transformer and we use it in electromagnets. We use it in what? In transformers, and we use it in what? In electromagnets. So you can be asked jam question. They can ask you that which magnet can be used? Which magnet can be used in what? In transformer or in electromagnet? Which magnet do we use in electromagnet? We use what? Soft iron in electromagnet. Why? They will not ask you why. Why? Because it can be easily magnetized and demagnetized. We use soft iron in electromagnet or in transformer. Why? Because it can be easily magnetized and what? Demagnetized. Now, for what? Still, where do we use permanent magnet? We use permanent magnet in what? In electric door. In magnetic door. Let me put it that way. In magnetic door. So you know those doors that are magnetic. So they use permanent magnet there because they are what? Because they retain their magnetism for a long period of time. You cannot stand it doing a magnetic door now. Then after some period of time, it gets, though it's still going to what? Be 40, but not that easily. Do you get it now? So we use permanent magnet in magnetic dot. So that is all for what? For types of magnet. Now under that too, we also have what? We also have properties of magnet. Now what are the properties of magnet? You should take note is that what you should take note under properties of magnet is that number one, magnet has two poles. It has the north pole and the south pole. Magnet has two poles. So let's have a bar magnet like this. It has two poles. So the north pole and the south pole. The north pole and the south pole. The north pole and the south pole. Now another thing you should take note is that what? Likewise in electric field, that we say like charges repel, while unlike charges what? Attract. Same here too. Like poles repel. Why what? Unlike poles what? Attract. So unlike poles attract, while like poles what? Repel. So we have two poles. What are the poles? What are the poles we have? We have the north pole and we have the what? The south pole. In what? In magnet. So number two is that what? Under the magnet, when magnets are, if you want to know if a material is magnetic or not, when you freely suspend it, approximately rests on the what? On the north-south direction. It approximately rests on the north-south direction when it is freely suspended. When it is what? Freely what? Suspended. So when we freely suspend it, it what? It will what? Where will it come to rest? It will come to rest approximately where? In the north-south direction. You should take note of that. Now, if you divide a magnet, let's say I have a bar magnet like this now. If I continue to cut the magnet, it keeps the what? The main property of the original magnet. Calm down. What do I mean by that? Let's say I have the magnet like this. I have a magnet now. So, and I cut the magnet here. You know, the magnet here is north and south before. Once I cut the magnet, then I'm going to have this. I'm going to have this. Right? So, this piece of magnet, you know, I've cut this into two. This piece of magnet and this one, let me call it A, let me call it B. This is the O magnet. I've cut it into two, into A and B. Now, the component of A and B, each component of A and the component of B individually is still the same thing as the O magnet. So whenever we divide any magnet, the small piece, each of the piece of the magnet, after dividing it, we also have the same property as the original magnet before we cut it. Like a chalk. Let's say I have a chalk now. I'm cutting the chalk into pieces. Each piece of chalk we have the same property as the what? As the original chalk. So that's what I'm trying to say here as a magnet. So once we cut any magnet, it's going to have the same property as this. Now we'll talk about the polarity of this. When we cut it, we'll talk about the polarity. This will be south and this will be north. So I will talk about how I determine that it is south and north in the next episode. Thank you.